Hi, this is a video demonstration of task 1.1. The goal of this task is to implement a custom generic class called vector which behave similar to C# built-in list, and it should support common operations like adding, removing, inserting, and clearing, searching element while handling the resizing internally. And to the implementation, we also mm, create the file called tester and vector. Let's go to the vector CS file, uh, and the top of the file we declare class public vector. This is a generic class, which means we can use it with any data type like integer, string, or even custom objects. This is based on generic concept in object-oriented programming, which allow our code to be flexible and reusable without rewriting it for different types. Inside this class, the code data structure is regular array. Uh, Here, this array is a private, and all integration go through public method. This is example of encapsulation, uh, where we hide the internal details and expose only what necessary. And also, we have two important properties called uh, integer count and integer capacity. Uh, Integer counts keep track of how many elements are stored, and capacity tells us how much space is currently allocated. So let's move, and there is a and when you come to the this method, the private avoid extend data, this method create a new large array and copy the old value into it. This makes the dynamic memory allocation, which is what real world dynamic array like list use under the hood. And I have implement the following method: uh, insert and clear, contains remove at, and to string to complete the functionality. So let's explain one by one. I'm going to the explain insert method. The insert method an element of a specific index and shift the following element forward and check for bounds and realize the array if needed. And it's useful for adding the elements in the middle of the list. And clear method is reset the vector to empty state by setting count to 0 while keeping the current capacity intact. And contains a method check whether the particular item exists in the vector, and it internally use the index of method efficiency. And this remove method find the first accurate of the given element and remove it. If the item isn't found, it return false. And remove add method remove the element at the specific index and shift the remaining element left to fill gap. And this toString methods override the default string representation to return the content of the vector in uh, readable format such as 1, 2, 3. And the all of these methods use safe bound checking and appropriate exception like index out range exception when the index is invalid. So let's move to the tester. class. This is the content. This class contains the main method, and it used to run series of automated tests to check if our vector class work correctly. And it start by creating a vector and then add sequence of numbers. After that, it perform all the cooperation by one, such as removing items, inserting at a specific position, searching the contents, printing the content with toString, clearing the vector, and even checking the proper exception and shown when invalid operation are attempt. And importantly, this check in sequence method help validate if the internal sequence of the vector met expected output for each test case. And also there's a this uh, line uh, should throw an index out of range exception, and test will fail if it doesn't. It tests in with message like success or fail, give us a clear summary of which fields are working with either fixing. And here we use try, try-catch block. The purpose of using try-catch block is to handle exception. This is to catch and respond to error that may occur during the program exception execution without crashing the program. So let's run the program. Here you can see the program is run successfully. You can see after all the tests run successfully, and see the success message. And this message is confirmed that the vector class behave as intended. So this is the end of my demonstration. Thank you.